Today we're going to talk about regression. By the end of this video, you should be able to determine the best model for a set of data and make predictions based upon that equation. First, a regression equation is an equation that best fits a set of data. By this we mean that the graph of the equation is very close to the data points in the set of data. So we are going to talk about 5 different types of regression equations: linear, quadratic, cubic, exponential, and logarithmic. We have already talked about all 5 of these graphs. In Algebra 1, you should have learned about linear regression and quadratic regression when you did line of best fit and curve of best fit. So when we find the regression equation, first we want to create a scatter plot, and that will give us a graph of the data, and then we can determine which type of equation would best fit that data. So if you have a somewhat or mostly linear looking scatter plot, such as that or that, it could have a positive slope or a negative slope, those would both be linear regression situations. Very rarely will a set of data perfectly fit into any one of these, but there will be one type that works better than another. Quadratic, remember, is a parabola. Could open up or down, and it will most likely not be a perfect parabola. Remember that a cubic kind of squiggles in the middle of the graph, or it could have a bigger squiggle. Exponential could be an increasing exponential function or a decreasing exponential function. Logarithmic functions tend to have positive a values, but you could, in rare situations, have one with a negative a value. Since most of this will be done on the calculator, there are a few steps that you have to remember. The first one is just a change of setting. We need to turn on stat plot. This will let us see the scatter plot on the calculator. So to do that, you want to go to y equals, scroll up to plot 1, and hit enter. There should now be a black box around the words plot 1. So you go to y equals, you go to plot 1, and then enter. And you only have to do this once. The rest of the steps you need to do every time you want to calculate a regression equation. So step 2 is to input the data. To do this, you want to click the Stat button and then click Edit. You want to type the x values in L1 and the y values in L2. So you go to Stat, number 1, which is Edit. Then your x's go in L1 and your y's go in L2. Then you need to look at the scatter plot. So after you have input the data, you would then click Zoom and 9, which says Zoom Stat. That will take you to the graph and change the window so that you can best see the scatter plot that you input the data for. So you go to Zoom and then 9, which is Zoom Stat. And you want to choose the best model. So if the scatter plot looks linear, you would choose to do linear regression. If it looks exponential, you would choose to do exponential regression. Step 4 is to get your regression equation. To do that, you go back to Stat, go over to Calc, and then you pick the appropriate model. Linear regression is 4, quadratic regression is 5, cubic regression is 6, exponential regression is 0, and logarithmic regression is 9. So you go back to Stat, go over to Calc, and then you have 4 options. Number 4, linreg, 5, quadreg, 6, cubic reg, 9 is lnreg, and 0 is exp reg. So this is linear, quadratic, cubic, logarithmic, and exponential. Let's look at an example. A diamond merchant has determined the values of several white diamonds that have different weights, measured in carats, but are similar in quality. The chart below shows each diamond's weight and its value in thousands of dollars. And then it gives us the data and asks, what is the exponential regression equation of the best model? So here it already tells us what type of regression we need to do. So make sure you read the question carefully. So let's start at the beginning. The first step was to turn on stat plot. You go to y equals, make sure that there is a black box around plot 1. Step 2 is to input the data. So we go to stat, edit. The weight will be our x values, the value will be our y values. So we can go ahead and type those in. Then we type the y values in L2. And always double check what you typed before you go on. It's a lot easier to catch your mistake here than later on in the process when you probably won't realize you made a mistake. Make sure you have all your decimal points where they should be. Make sure you didn't skip a number. Make sure you didn't mistype something. Then you can go ahead and move on to step 3. Step 3 was to pick the best type of equation to model this data. But our problem tells us that we are going to do an exponential regression. So we don't really need to do step 3, but I'm going to show you how just in case. You click Zoom and then 9. Now, you might think that this is linear, but we'll see in a little bit that it does have a slight curve to it, which is why the problem tells us to use an exponential regression model. So always make sure that you pay attention to the words in the problem, because sometimes the data can be a little bit hard to interpret. Then step 4 is to get the equation. So we go to stat, go over to calc, and then we're going to click 0, which is exponential regression, and hit enter a few times. For each type of regression, the first line tells us the format that the equation is written in. So this tells us that our equation is y equals a times b to the x. Then it tells us what a and b are. I do not want you to just copy down this screen. You need to plug those numbers in to the equation that they give you. So we're going to round to 3 decimal places for all of these regression problems. So we're going to go ahead and write down our equation, which will be y equals 4.068 times b, which is 1.382 to the x. That's what this caret means, is that the x is the exponent. So make sure that you are rounding correctly. You should always round to 3 decimal places, not just truncate the number. So we have our exponential regression equation. Part B says determine the value of a 2.5 carat diamond. So 2.5 was not given as an x value in our chart, but we can use our equation to figure it out. So since 2.5 is a weight, that is an x value, we just need to plug 2.5 in for x. So we can go back to our calculator and type in the equation. So this gives us 9.134 as our answer. But since this is a word problem, we need to check the units of the y values in the chart. And it says that the value is measured in thousands of dollars. So this means that this diamond is actually worth $9,134. Part 3 says approximately how many carats is a diamond that is valued at $7,000. So we can see from the chart that it's probably somewhere between 1.5 and 1.75 carats. 7,000 will be our y value. Now here's where we got to be careful. The value is measured in thousands of dollars. So we're not going to plug 7,000 in for y. We're just going to plug 7 in for y. And then we need to solve for x. Well, we didn't really learn how to solve exponential functions yet, but we can use the calculator to help us figure this out. If you go to the calculator, you go to y equals. If you type one side of the equal sign into y1 and one side of the equal sign into y2, we can use the graph to help us figure out the solution. So we have 7 equals 4.068 times 1.382 to the x power. Then I'm going to go to the graph. So the horizontal line represents 7, and the red curve is our exponential. Now, wherever these two intersect will be the solution to our equation, and the calculator can calculate the intersection for us. If you look right above the trace button, you see calc, that stands for calculate. So if you hit second trace, one of the options is intersect. Then it's going to ask you some questions. It asks for the first curve. You just click enter. It asks for the second curve. Just click enter again. And then it asks you to guess at what the solution is. If by chance there are two solutions, so your equations intersect at two different places, you would want to scroll toward one solution and hit enter, and then do this process again. Scroll toward the other solution and hit enter again. Then it gives us the answer down at the bottom. It tells us that x is 1.6776, so 1.678, and y is 7. So that will be the solution to our equation, 1.678 carats. And that makes sense with what we observed at the beginning. We estimated that it was going to be somewhere between 1.5 and 1.75 carats. So to do this, we did second, trace, and number 5, which is intersect. Now, this little box over here in the corner says, how do we change the window if needed? Well, sometimes you might not be able to see where the lines intersect. So in that case, you need to zoom out. There are two ways you can do this. You can either click zoom and then zoom out, and then you'd have to hit enter for it to actually zoom out. Or you can go to window. So when we started this problem, we estimated that the answer was somewhere between 1.5 and 1.75. So we can adjust the x and y values to make sure that what we think the answer is included in the window. So we would want to change the x min and max to include what we thought our answer would be, and change the y min and max to include what our y value is, which is 7. So sometimes you might have to adjust the window or zoom out to make sure that you can see where the graphs intersect. But as long as you can see the intersection, the calculator can find the intersection for you.